Hello everybody, this is Horned Frog Engineering, and I wanted to show you a very useful technique that I love to use for my engineering classes. It's been very helpful over the years, and this is called using pretty much solving systems of equations using your TI-84 or TI-83 calculator like this. This is a TI-84 plus CE. So usually professors, especially for classes like statics, circuits, dynamics, your professor will let you use calculators like these so that you can solve systems of equations. Or you can use a calculator like this one, a TI-36X Pro. But this one is very limited and it only allows you to solve three unknown variables, whereas this is what you're going to use for your FE exam, by the way, and you're probably not going to solve more than 3 variables for those exams, but usually if you do have to solve more than 3, your teacher will usually let you use one of these calculators. So if you're doing it by hand, it'll, for those of you guys that are super talented and smart, it might take you guys, if you're solving 3 or more variables, it might take you like 5, 10, 20 minutes. But for those of us who are not as talented and smart as some of y'all are, having this tool handy is super helpful. And but anyways, let's begin. Let's put aside the calculator real quick. This is an actual example from my circuits class that I took this past semester, where I had to solve it was a mesh analysis where I had to solve three variables, or 3 unknown variables, using 3 equations, and the 3 unknown variables are I1, I2, and I3. And you have to have 3 equations to be able to solve 3 variables, or if you're solving 5 unknowns, then you have to have 5 equations. Anyways, let's get to it. First, we're just going to organize our work. Your professor is going to want you to show your work. Usually, all my professors usually want me to show my work so that I can get partial credit even if I get something wrong, and not just outright put on the answer at the very end, because they usually don't give credit for that. So what we're going to do is, these are the equations I got. I'm not going to bore you guys with what the circuit looked like, but these are the 3 equations I was able to get from that circuit. And we're going to first start off with our I1. We're going to set up an augmented matrix. We're just pretty much organizing our variables and our constants right now. And then we're going to set up an augmented matrix, and then we're going to transfer that into our calculator to be able to solve in a few moments. So for I1, for the first equation, you have a negative 1.6 on your coefficient. For your I2, it's 1.6. For your I3, it's negative 1, and then 0 on your right side. And then for the second equation is 13 for the coefficient, and then negative 8. And then this one doesn't have an I3, so you're just going to put a 0 on the I3 for that one. And then on the right hand side, it's 4. And then for I1, negative 8, 18, negative 10, and 0. So now we're going to go into our calculator, and I turn it on, go to second matrix, just a moment. Okay, go to second matrix, and then edit. I'm just going to choose matrix A. Like I got a bunch of matrix over here, but I'm just going to choose matrix A. You can choose any letter that you want. Choose matrix A, and then this matrix is a 3 by 4. That means it's a 3-row matrix, 1, 2, 3, and a 4-column matrix, 1, 2, 3, 4. So 3 by 4, and then we're just pretty much going to put all of our numbers one by one, being careful not to mistype any numbers, because it's a very common mistake that I have whenever I rush things. So make sure you're very systematic in doing it and try not to rush it, and then check your work. So the last row is negative 8, then 18, negative 10, 0. So again, we're going to double check, because it's so easy to make a mistake, especially if you're under pressure and rushing during an exam. So now it's negative 6, negative 1.6, 1.6, negative 1, 0, 13, negative 8, 0, 4, and then negative 8, 18, negative 10, 0. So Now we have our matrix set up, and what you're going to do is press second quit, and then you're going to go back to second matrix, go to math again, go to math, go all the way down to RREF. And once you're at RREF, you press second matrix, and then you put RREFA, row reduced echelon form. That's what that means. But so if you're taking linear algebra, you know what that means. But it's just RREF. And then you're going to press enter, and then that solves your I1, I2, and I3. So for us, this is going to be our I1. Our I1 is equal to 0.088. If this is a circuits class, they're going to want you to put the units. So it's 0.088 amps, and then negative 0.355 amps. I3 negative 0.711 amps, or if it's a statics class, it might be kilonewtons or pound force or something like that. But this was a circuits problem, so we're trying to find the current I1, I2, I3, and that is our answer right there. We could also do this with not just a 3x3 or a 3 unknown 3 equation matrix, but we could go as high as 10 or 20 if we wanted to, but that gets very complicated. Usually you won't see some stuff like that, but I did see something like this during one of our homeworks. It was a 5 unknown, and it had 5 equations. So let's do something like that again, going through it one by one systematically, what that looks like. First thing we're going to do is we're going to organize our coefficients and constants. C, and then we're going to set up an augmented matrix. All right, so our first VA is a 1, VB is 3, and then there's no VC, so just be careful. It's easy since there's no VC over here. Like you might be mistaken to put a 1 on the C, but there's no VC, so that's going to be 0. And then if you could put a 0 VC up here if you wanted to, just to make it clear, but you can do that as well. Sometimes I do that. And then your VD is 1, negative 4 VE, 0, and then again, be careful, there's no VA, so put a 0, and then 1 VB, 3 VC, negative 4 VD, negative 10 VE, 0, and then 10 VA. Again, be careful, there's no VB, so put a 0 on that one, and then a 4 VC, and then 0, 0, 5, and then fourth equation is 5 VA. Again, be careful, 0, 0, 0, and then we have 1 VE, and then the 3 on our right hand side. 11 VA, 0, 1 VC, negative 1. Be careful with your negatives. That's an easy mistake that I usually sometimes make, is sometimes I put a positive 1 instead of negative 1. So to make sure you double check your work. And now we're gonna input it in our calculator, and then we're gonna go to second matrix, edit matrix A. So this one is 1, 2, 3, 4, 5 rows and 6 columns. So it's a pretty big matrix, and we're gonna input everything one by one, making sure that we do it systematically, not make any mistakes. 1, 3, 0, 1, negative 4, 0, 0, 1, 3, negative 4, negative 10, 0. If you want to fast forward, you can. This can be tedious, but you're still saving a lot of time rather than doing it by hand. If you're going to do this by hand, this would take you probably it'd probably take me like 30 minutes, 45 minutes to try to solve this. And then 0, 1, -1, 0, 0, 0. So I'm gonna assume everything is good. I'm not gonna double check it just for the sake of the video. I don't want to make it any longer than it already is. So now we're gonna go to quit, second quit, and then go to second matrix. Under math, go to RREF, second matrix, and again that's matrix A, and then this is the answer that we get. This answer right here is your VA, VB, VC, VD, and VE, and these are in voltage. I was doing a this is a not a mesh analysis, but a nodal analysis where I had to find the voltages, VA, VB, VC, VD, and V, and that is your answers.